Okay, so welcome back. Now today we're going to talk about the Arduino and the accuracy of the Arduino. And we're going to talk about some misconceptions or misunderstandings that I think a lot of people have about how to make this an accurate reading. And we're going to talk about some of the information you may see on the internet that kind of leads you towards incorrect results. So we're going to help you to understand how this works, how the analog to digital converter works, and how to set up your Arduino so you get some accurate results. So I've got an Arduino Uno here, and you can see over here I've got my bench power supply, and I've set it for 4.00 volts DC output. And I'm feeding that to this breadboard. Now you can see I've got a meter hooked up, off by 0.001 maybe, that bounces around, but you can see they both pretty much agree. I've got 4 volts coming out, and I'm feeding it into the Arduino into one of the analog inputs, analog input 0. So I've just got these 2 wires going to analog input 0 and ground. And you can see it's being fed by USB from my computer. So we would expect that we're going to put together a very simple sketch that you see, the same sketch that you see in many places on the internet, about how to grab data from the analog input and convert the 0 to 1023 value back into a voltage, and it should match our 4 volts. So we're going to put together that simple sketch, run it, and see how accurate the results are on the computer compared to what our meters are saying over here. So let's run over the computer and see what we get. Okay, so here we are on the computer, and I put together a very, very simple sketch. It's probably very similar to a sketch you see all over the place when people are showing you how to read from an analog pin on the Arduino. And I've basically set up the analog pin as A0, and the void setup, I just do serial.begin 9600, and I'm setting that analog pin A0 as an input. Very simple. Now in the loop, what I'm doing is I am doing an analog read from that pin, and I'm setting that equal to a variable called logval. And that's an integer because, as you probably know, the analog read converts the actual voltage value coming into the analog pin into an integer. And that integer is between 0 and 1023. And then what I do is I calculate, I go back and from that value, figure out what the actual voltage is. And we were inputting about 4 volts. So this float value of voltage will be the 0 to 1023 log val times 5 volts over 1023. And this is the equation that you see very often associated with the Arduino, where you assume, okay, 5 volts coming in will give a value out of the Arduino of 1023. So we're going to take the integer from the analog read, multiply it times 5 over 1023, and that should give us a voltage of around 4 volts, okay? And then we're just going to do a serial print line of that voltage, wait for a second, and redo it, okay? So let's take a look at the serial monitor and see what result we get. Wow. So we're feeding in 4 volts and we're getting 3.85. Wow. Now something is wrong, right? I mean, you shouldn't be getting 3.84, 3.85 when you're feeding 4 volts into the Arduino. And when you use this equation, this is what you get. So what we're going to do is we're going to see what's going on here. Why am I only getting 3.85 when I should be getting 4? I'm using the right equation, right? Well, we're going to step back and look at how this works, how the Arduino works, and how it does this, what's called analog to digital conversion, and figure out what's wrong with this and why what you see very often on the internet just isn't true. So let's step back and take a look and see what's going on. Okay, so here's a simple representation of what's going on with the Arduino when we feed it a voltage and we ask it to give us a number that represents that voltage. So let's say, for example, I've got this varying analog voltage that's appearing at the analog input pin of the Arduino, and I tell it to sample that voltage at a certain period of time, and it samples 4.83 volts. Well, the job of the Arduino is to convert that voltage value into a number that represents the voltage value. Unfortunately, it can't directly tell us 4.83 because of some limitations, but it's going to give us a number that represents that voltage. So it's basically a voltage to number converter. When you do an analog read, it converts a voltage into a number. And the number is something that we have to agree on with the Arduino so we know what that number represents in terms of voltage. Now we could, the Arduino could convert it to a color or a range of colors. It doesn't matter as long as we understand what the colors mean in terms of voltage. We need to convert back whatever it sends us. We need to be able to convert that back into an actual voltage. So now there's some problems we need to deal with. As I said, it basically converts a voltage to a number, but the converter, the analog to digital converter in the Arduino, doesn't deal with decimal points, okay? So it's not going to tell us 4.83 because it doesn't know what a decimal point is. So that's one of the big problems we have to deal with. And if it can't deal with decimal points, you're going to also see that you're going to need a lot of numbers to accurately describe voltages. So for example, if it's 4.83, it could even be 4.82 or 4.81 or 3.24. And if you're going to represent each of those little increments, you're going to need a lot of little increments to represent even 0 to 5 volts. So, how are we going to deal with it? If you can't do decimal points and you need a lot of numbers, how are you going to deal with it? Well, if you think about it, how about if we multiply the value we get times 100? So instead of, we get 4.83 coming in, we multiply that times 100, that'll give us 483. So now you don't have to deal with decimal points. That could be a good solution, right? 4.83 times 100 is 483, and maybe the Arduino just sends to us the number 483, and we know how to convert it back to 4.83. So maybe we can have like 500 values that represent from 0 to 5.00 volts. That might be a solution, then we don't have to deal with the decimal points. Well, actually, the Arduino does something like that, but it does it even better. So instead of multiplying times 100, it multiplies times greater than 200. And as a result, it gives us 1,024 values to play with. So it will convert that 0 to 5 volts to a value between 0 and 1023. Keep in mind, 0 is a value. The total number of values, including 0, is 1,024. But the maximum value is represented by the number 1,023. So what it does is it will take, for example, an input that goes from 0 to 5 volts, and when it sees 5 volts, it will return the value of 1,023. When it sees 0 volts, it will return the value of 0. So if 5 volts equals 1023, then 4.83 volts is less than 1023. And if you do the math, 4.83 comes out to 988. So if it sees 4.83, it will send the value back to the computer, the value of 988. Unfortunately, if you're a user on the computer, you need to figure out what does 988 mean and how do I convert that back to 4.83. So there has to be an agreement between you and the Arduino of what that 988 means and what the 1023 means. In this case, we have to agree that 1023, if I get a number of 1023 from the Arduino, I have to know that that is equal to 5.00 volts. So we have to agree on what this conversion is. What the Arduino does is it uses what's called a reference voltage, or a VREF, internally to make that conversion. So for example, if the VREF is 5 volts, it will say, okay, VREF is 5 volts, therefore that's what I'm going to use as my 1023 to send back to the computer. However, we have to tell the Arduino what that VREF is. We have to agree. Is it 5 volts? Is it 5.1 volts? Is it 4.9 volts? We have to know because we're going to have to convert back. We're going to have to take that 988, and if it's not 5 volts, then we're going to get an incorrect value if we convert the 988 back to voltage. If that is 5.1, for example, it's going to give us 988 isn't going to be the correct value, okay? So we have to agree with the Arduino on what the conversion is between voltage and 1023 numbers. One of the big misconceptions or misunderstandings around the Arduino is that it receives on the USB port to power the device, it receives 5.0 volts, okay? There's a lot of discussion and a lot of code and a lot of assuming that the value coming in from the USB is 5.0 volts. That is wrong, all right? In fact, it's rarely 5 volts. It's all over the place. It's not 5.0 volts. So if we think it's 5 volts and we do our conversions based on 5 volts like this, we're going to get wrong readings, okay? So let's step back and look at what we can actually expect from USB voltage, because the Arduino uses that incoming voltage on the USB to determine the references and what it is going to set equal to 1023. Here is a table from the USB 2.0 spec. Now you can look at the more recent USB specs. I just happen to have the 2.0 spec hanging around. And in section 7.3.2 under bus timing, electrical characteristics, table 7.7 or 7-7, DC electrical characteristics, it defines what the range of USB voltage can be supplied to your device. And it's called, see here, it says V-bus, all right? And if you look at the connector for USB 2.0, you've got 4 pins. You've got a ground, you've got 2 data pins, and you've got a power, which is the 5 volt nominal voltage. But as you can see from the chart, it's not 5 volts. For a high power port, that V-bus can be minimum 4.75 volts up to 5.25 volts. So you can start to see if I'm using 5, if I'm assuming 5 is equal to 1023, but I'm actually getting 5.25, I'm going to have incorrect readings, all right? So this is one of the important things you need to know about the analog to digital conversion process. The Arduino could be working on incoming voltages from 4.75 to 5.25, or if it's a low power port, it can be even lower, 4.4. So we have to understand this and we have to apply it when we are doing readings. So what I've done is I have gone through a bunch of my devices that have USB ports that supply voltage to devices, and I have measured what the no load, nothing else connected, I'm just measuring the voltage, what the no load voltage is on those ports. So I've got a battery pack. It's basically a 10,000 milliampere battery pack that you can use to charge cell phones and that kind of thing. The no load voltage is 5.09 volts. It's not 5 volts. A USB charger that I plug into the wall outlet, it's 5.14 volts. My laptop USB port is 5.09. My bench power supply that we looked at previously is 5.1. A USB hub that I use to power all my devices is 5.25. Desktops, I've got 3 desktops with USB ports. One is 5.12, one is 5.06, one is 5.03. So now we know that the voltage coming over the USB into the Arduino could vary between 4.75 to 5.25 volts. Now what the Arduino does with that is it uses that voltage to generate a reference. The reference is called Vref. And that Vref, it sets equal to 1023. So for example, if my Vref is 5.1, if it determines, it takes in this USB voltage, converts it to a Vref of 5.1, if I feed in 5.1 volts into this analog input, it's going to send to the computer 1023. Because it thinks that Vref is 5.1, and that is equivalent to 1023. If Vref is 5.2, if it sees 5.2 coming into this analog input, it will send 1023. So we have to be very, very, very careful to understand what Vref it's using to equate to 1023 which is the analog read value it will send back to the computer. Here's an example. If I have 5.25 volts coming in to the USB from my USB hub, the VREF that it will generate, and that's the voltage you measure at this 5-volt pin, is 5.18. So it thinks, based on this input voltage, it thinks that VREF is 5.18. So as far as the Arduino is concerned, 5.18 volts equals 1023. So if it reads 5.18 on this analog input, it will send back to the computer, okay, 1023. And if the computer user thinks that 1023 is equal to 5 volts, he's going to get a very wrong value. What that means is this code on the Arduino that you see everywhere in a lot of examples is not right. The voltage is not whatever the read value of 0 to 1023 times 5 over 1023. In the case we just showed, it's 5.18 over 1023, okay? So you need to know what that VREF is so you can fill in this number in the equation. So it's very, very, very important. So let's go back and see if we can figure out what the VREF is and fill that into this equation and see if it fixes our initial errors. Instead of 4 volts, we're getting 3.85 volts. Okay, so here we are back at the bench, and I've got pretty much the same setup as I had before. I got 4 volts coming out of my DC power supply, and I'm feeding that into the analog 0 input of the Arduino. And what I've got here is I've got a USB current and voltage meter, and you can see that it is showing that I've got about 5.2 volts coming through the USB into the Arduino. What I've got here on my meter now is I am measuring the 5-volt VREF from the Arduino. I'm connected up to the 5-volt and ground, and I'm measuring 5.14. So it's taking 5.2 in from the USB and converting that to a VREF of 5.14. So from what we talked about before, I should go back to my equation in the sketch, and I should change from 5 to 5.14, since that is what the Arduino is using to signify 1023. So let's run back and change that to 5.14 and see how that improves the accuracy of our readings. Okay, so here we are in our sketch, and we'll go down to this equation. And now that we know that the VREF is 5.14, we'll change that from 5.0 to 5.14. And then we will upload it, compiling and uploading. Now we'll look at the serial monitor and see what it's reading from the Arduino. Right on the money, 4.0, 3.99. That's matching almost exactly what we're getting on the DC power supply. Again, you need to be very careful. If you're going to use the USB port for powering your device and you're not going to have any external references, you need to understand how this works if you want accurate results. Now, in future video, we'll look at other ways to provide a reference. You can provide external references into your Arduino, and you can have a regulated power supply, and you can make it whatever you want. And that does have some benefits, but we'll look at that in future videos. Anyway, if you like any of these videos, please like and subscribe, hit the bell notifications, and most of all, let others know that we're here so we can get some more viewers. Otherwise, hope that helps. Take care and have a really good day. Thanks.